Right, hello. I will just let everybody arrive. Um, Maths is what mostly we should be doing this week because we should have done various things related to maths over the weekend. Or if you came on a Thursday or a Friday, then you still were doing physics, in which case I have that ready as well. So, assuming most people, yeah, the first hour of this will just be maths, yes, because it's Key Stage 3. Um, Fractions, decimals, percentages is what most people in Key Stage 3 did over the weekend. Um, there are three different booklets, all of which I have ready. If you have any questions from any of those, which I think there'll be fewer of today because it's just the kind of thing that you probably know the answers to more. So then feel free to ask. Otherwise, I will pick a few questions and do them to talk about this topic. I think I'm going to just start talking about this question until more questions come in. Um, but this kind of thing with percentages, especially when you don't have a calculator, is very important that you are comfortable with because regularly, as you know, you have to find a percentage of a number without a calculator. And you normally do things like 10% and 1% and stuff like that to get to the bit that you want to get to. And so this little question is a good way of just making sure you remember those things. For example, finding 10% of a number means dividing the number by 10. 20% of a number is dividing the number by 5. Rarely would you do that. You'd normally find 10% and double it, but still. Find 5% of a number also, you probably wouldn't do that too much, but it is dividing by 20. And 1% of a number, which you will do a lot, is dividing the number by 100. So just as an example, while any other questions come in, if I wanted to find 38% of 200, 600, let's say, um, which is a very common sort of question where you have a number with two zeros at the end of this when you're doing these. Um, I would personally, without a calculator, remember, find 10% of this number. 10% of a number means dividing it by 10. That would be 60. Then I would jump to 30% because I'm trying to get to 38%. 30% of the number means triple what we have got so far before. 60 times 3 is 180. That's 30% done. We now need to get to the 8%. To get to 8%, I can find 1% of this number first by dividing it by 100, because that's how you find 1% of a number. And again, conveniently, because this is a multiple of 100, to find 1% of it is easy. It is 6. Then I'm going to find 8% of this number by timesing this by 8. If you times 6 by 8, you get 48. And so finally, we have got to the 38% because we've got 30% and 8%. And if you add those two together, you will get what 38% is. 180 plus 48 is 228. For that made up question, just because. I have a question. It's question 4, booklet 3, which is not the one I was doing, but it's this one. So let's have a look at it. In 2004, a newspaper published this incorrect report. Houses cost £60,000 1 year ago. They now cost £80,000. This is a 25% increase. We need to make this correct because there's a few mistakes. A good question, this actually. So houses cost £60,000 a year ago, and they have gone up by 25%. We need to figure out what they now cost. So in other words, we need to increase 60,000 by 25%. There are a couple of different ways to do this. You could find 25% of 60,000. I'll do it both ways because I've got time today. So, well, there's a quick way to do this. To find 25% of a number, that's just dividing it by 4, right? And to divide any number by 4, you can halve it twice. So half of 60,000 is 30,000, and half of 30,000 is 15,000. So if we have increased by 25%. In this case, that's an increase of 15,000, which means that they now cost 60,000 plus 15,000, which is 75,000. Alternatively, I think we put on the front of this particular booklet, we did calculator allowed. There is a quick way to increase by 25% if you have a calculator. Let me get my calculator. Where what you can do is take your number. If I want to increase it by 25%, I can just multiply it by 1.25. That immediately increases any number by 25% if you times it by 1.25. And it takes you straight to the answer to £75,000. And that is the answer here. This is a good question, though, because things change in the next part. Now they're saying, okay, let's say houses cost £60,000 a year ago. Now they cost £80,000. What is that as a percentage increase? Okay, so just to be clear, this was a mistake because this was not a 25% increase to get from 60 to 80. Because we know that 60 to 75 is a 25% increase. But what if it did go from 60 to 80? What is the percentage increase? There is a little formula, and again, depending on the lesson, you might not have got to this. But the formula for what's called percentage change is exactly what has just been said. New number minus old number over old number times 100. That's a good way of saying it. Okay, I want to say it slightly differently to you, but it's the same thing, which is that if you have two numbers, in this case, 60,000 and 80,000, okay, and you've gone from there to there, and you want to work out the percentage difference, percentage change, then you take the difference between the two numbers, divide by the original of the two numbers, or the old number in your case, and times the answer by 100. So the difference between these two numbers, 80,000 and 60,000, is 20,000. Divide that by the original, what we started at, which is 60,000, and times by 100. And I think that's 33%, isn't it? 33.3% is what you want to write here. Okay, so that is a 33% increase. In fact, you can sort of tell by looking at it, because if you look at how much this has gone up by, it's gone up by 20,000, right? And what is 20,000 or 20 as a fraction of 60? Isn't it a third of it? So 33% is a third. So that's why it's 33%. Is there more? There is. Houses cost something a year ago. They now cost £80,000. This is a 25% increase. What is the value there? Okay. So remember what I said earlier, that if you have a number, let's say this box, and you want to increase it by 25%, a quick way of doing that is by timesing any number by 1.25. And what we're saying is we had a number in this box, we times it by 1.25, 25% increase, and we got to 80,000 as an answer. So now if I want to figure out what's in this box, this is a rearranging an equation. The opposite of timesing is dividing. So to work out what's in this box, I can do 80,000 divided by 1.25. And this is why you need a calculator, because you don't want to do that without it. And you will get 64,000. That is the number that goes in that box. That if they were 64,000 a year ago, or sorry, if they cost 80,000 now after a 25% increase, they must have been £64,000 before, and then we've increased by 25%. Okay. While I'm here, because nobody's asking any more questions, I'm going to keep going through this. This is if you did your booklet and you are here having done your booklet, and you don't have many questions from what you did because it was quite easy, then in principle, this booklet is the sort of the year 9 one that we gave this week, which in theory has slightly harder questions on it. It doesn't not much harder, but so it's useful probably to go through this for everybody. 15% of 540. You can almost do this in your head, almost. But 10% of this number is 54, just take off the 0. 5% of this number would be half of the 10%, which is 27, and therefore 15% must be 81. Yes. 12B, is that from this one? Just need to tell me which booklet one, two, three. I assume you're telling me booklet three, but tell me if not. Booklet two. Okay, we'll switch over. And let's look at question 12. Oh, I remember this question. It didn't make any sense to me. Okay, right. Let me just open up something. Whoa, got loads of questions. 540 over 100 times 50. Yeah, that would work as well. It's just slightly harder to do 540 over 100 times 15 without a calculator. Slightly hard. I'm not saying it's impossible, but that's what you have to just be careful of in terms of understanding that these questions can be with a calculator or without a calculator. Either way, you need to make sure you do it correctly. So it's a little bit harder to do 5.4 times 15 without a calculator. A little bit hard, not much, but it's a little bit. Right, yes, I will, and I'll do 12B, but I need to do 12A first. Hang on. Um, so I remember this didn't make much sense, this question. Simon is growing vegetables in three vegetable patches. About 50% of this vegetable patch is for carrots. Okay. About how much is for cabbages, about how much is for lettuces. Well, I mean, it's a weird guessing question, this, because that must represent 50%, but cabbages is slightly bigger. So you could do, I suppose, um, I mean, the mark scheme says up to 35% for cabbages. So you might do 30 and 20. I think that feels correct. Okay. So I would say about 30% is for cabbages, about 20% is for lettuces. Um, right, B then. About 1/8 is for beetroot, okay? Fill in each gap for this fraction. Okay, so they've told you this is 1/8, okay? That means all of this is 7/8, right? And so the question is, just checking what I would do. I mean, personally, what I would do is just go, well, that looks virtually the same as this in terms of size, right? So peas, I'd do 1/8, and then that leaves 6/8 for broad beans. The mark scheme doesn't quite say that, but I'm going to stick with what my gut here because I think that is correct. Um, yeah, that's what I would go with. Um, and then, because it has to add up to one whole, right? 1/8 plus 6/8 plus 1/8 is one whole. I'll just do C as well. About 4/5 of the vegetable patch with potatoes. Draw a straight line to show how much is potatoes. So you've got to split it into roughly five sections. So I mean, like there, 4/5 there. Yeah, you get the idea. And then shade that roughly, which shows the bit for potatoes. Okay, any other questions? I don't seem to have any other questions. So I'm going to continue, go back to this one and have a look at what we've got here. These important conversions and stuff. Now, I'm going to try and, to some extent, do most of these things, assuming I don't have a calculator until I absolutely need one. So if I needed to convert this decimal into a fraction, very easy to do this. If you have a decimal to a fraction, you take this number, which is after the point, put it on the top, and on the bottom, if there is one digit after the point, put a 10. And that is it. And simplify it if you want, but in this case, it doesn't simplify either. This is 70%. I'll just fill this in before I look at the questions that have just been asked. Question three, booklet three. I think I'll come back to that in a second. Did I do that? No, I didn't. I'm going to. I'll finish this off. The 15% as a decimal is 0.15. You just move the decimal point back two places, and then 0.15 as a fraction. You can just put 15 over 100, or you could simplify it to 3 over 20 if you divide them both by 5, but it doesn't ask you to simplify, so I'm happy with that as it is. Question three. This might need a calculator. Right. Joe made 60 necklaces. It cost £1.20 to make each necklace. She sold 75% of the necklaces for the full price of £5. She sold the rest at half price. What was her profit? So just remember, if I want to work out a profit in any situation in a business, I need to work out how much money I've brought in. That would be my income, and take off anything that it cost me. So minus my costs. Okay. So what we can do easily is work out the costs here because it tells you it cost her £1.20 to make each necklace. Okay. I'm going to try and do this without a calculator for now. Let's go with it. Right. So to work out the cost of these 60 necklaces, you would do 60 times 1.20. Um, which I think is £72, isn't it? Yeah, it is. So if I were going to do this without a calculator, a few ways to do this. You could just ignore the decimal points and basically do 120 times 6, which is 7,200. Because 12 times 6 is 72, and then put the two zeros on, and then put the decimal point back, and you get £72. So it costs £72 to make these necklaces. So if we just go to here, I'm going to take away £72 from any income that I have. Let's work out the income. In other words, your sales. I want to do sales. I think that's a better word. Okay. She sold 75% of the necklaces. Right. We stop there for a moment because we had 60 necklaces. We've sold 75% of them for £5. So we need to figure out how many that is. How do we work out 75% of this 60? Well, you could times 3 is 45. Um, well, I'm trying to do this without a calculator, so it's easier. So what you could do is work out half. So 50% is a half, right? So half the necklaces is 30 necklaces. Half of that again, which is a quarter, is 15 necklaces. And a half and a quarter makes three quarters, which is 75%, which is 45. Or you could do it the longer way and do 10%, 5%, and all that stuff. And you should still get to 45. So we've sold 45 necklaces for £5. How much money does that bring us? 45 times 5 is 225, I believe. 225. We have earned £225 from selling 45 of those necklaces. But we've still got some necklaces left. We've got 15 necklaces left that we have not yet sold. And we've sold the rest at half price. Half price means at £2.50. Okay. So we need to figure out what 15 times £2.50 is. Again, I'm doing this without a calculator just for the sake of it. I suspect you might normally have one for this. 15 times £2.50. How would I do that? I would probably do 25 times 15 and then put a zero on later. I do it like this. I appreciate not everybody does. Okay, so 15 times 250 is 3750, but then I've got to put the decimal point back in, so it's £37.50. That's how much I've earned from selling those other 15 necklaces at half price. Um, and I need to add that on to my 225, which I might just do down here to work out my total sales. That means that my sales were £262 and 50 pence in total, right? So that's the 225 from the first 45 necklaces, and then another £37.50 from the stuff we sold off quickly at the end. And then this calculation gives you the answer. So £262.50 minus 72. Just be careful when you're dealing with money and stuff and making sure your points are in a line when you do adding or minusing. So 0, 5, 2 take away 2 is 0. That 16, 9, £190.50 looks to me like my profit from this exercise. And that should be it. Right, there's loads of questions. Question 15, booklet 2, 5-year 9 booklet. Is that question 5 in the year 9 booklet? Is that question 5, year 9? Is that booklet one or booklet two? Just making sure you get the correct number on from the front. I'll do 15 from booklet two first. Yeah, just make sure you say the booklet number, just in case you got a different one. Um, question 15. Booklet two. Oh. Something out of 10 is the same as 70%. Well, look, 70% is 70 over 100. If I need this to be out of 10, then I would just take a zero off this and take a zero off the top one as well. 7 out of 10. 10 out of 20, well, 10 over 20 is a half, right? And what's a half as a percentage? 50. Complete the sentence. Something out of something is the same as 5%. I mean, I would just put 5 out of 100 because it's just the easiest answer. Because 5 out of 100 is the same as 5%. The lines above and below, nothing. Just space for you to do some working out if you want to. I mean, it's just that. Just because there's lines doesn't mean that you need to worry about it. Yes, if you've got a booklet one and you have questions from it, I have it ready to go here. So what you need to do is specify if you've attempted some of these questions, any that you found difficult, because that's how this works, rather than I'm not going through the whole thing, usually. Right, that was that one. Yeah, so in a question, just because there's lines, don't let that phase you, especially in maths, because they overdo it sometimes with lines and maths. Um, but that doesn't mean that you need to use every line and stuff like that. It's just there in case you need to write something. Um, okay, now complete the sentence using different numbers. Oh, okay, fine. Well, since I've done 5 out of 100, um, could I not do just double everything and do 10 out of 200? That'll be the same as 5% as well. That works. Question one in this booklet. Okay. I mean, this is really, really easy. With a calculator, it's easy. 2 million tons of glass bottles and jars were thrown away in the UK. 38% of these were recycled. How many tons were recycled? This question is saying, what is 30%, 38% of that number? Which I appreciate is awkward to do without a calculator. It's also not impossible to do without a calculator. I'll do it without a calculator. Um, To work out 38% of this number, what I'll do is work out 10% of this number. 10% of this number is 200,000, as in you just take off one of the zeros. Okay. I need to get to 30%. 30% of that number means tripling this number, so it's 600,000. 1% of this number is taking off two of the zeros, so that's 20,000. 8% of this number is this times 8, which is 16, and then all of the other numbers. 160,000. And to get to 38%, we will add this to this. That gives you 38%. 600,000 plus 160,000 is 760,000. If you wanted to demonstrate that with a calculator, then you would just do, to find 38% of a number, the easiest thing to do is turn it to a decimal, 0.38, and times it by the number 2 million to make sure you get the number of zeros correct. And then you get 760,000 on the calculator to prove that that worked well. Question 5 year, I'm going to do question 5 year 9, even though I'm not sure that is the one you actually want. I've done it, but that's question 5 on that one. That was not a question, surely. This one, not the easiest, but let's do that. I just did question 1, didn't I? Did do question 1. Yeah, did question 1. Okay, fine. Done that one. So this question 5, which is to put these in order. Ooh, usually it is easiest to put these kind of things in order if they are percentages or decimals. Like with fractions, it's very hard to put them in order unless your denominators are all the same, which is often quite hard to do, but also not impossible. So this is how I would do this question. This is already a decimal. This is already a decimal. This is easy to make a decimal. It is 0.52. This one, if you have learnt what 1/5 is a decimal, which is 0.2, then you'll know that 2/5 is double that, which is 0.4. So this is 0.4. Right. Now that they're all decimals, the next thing to do is make sure that we have the same number of digits after the point in all of them. So you see how some of them have got 2 and some of them have got 1. The ones that have 1, just put a 0 after them just to make them the same length. Then all you need to do is look at these numbers and order them from smallest to biggest. So for example, 25, 0.25, is the smallest out of 25, 40, 60, and 52. And so that is my smallest. The next smallest is the 40, right? So I'm going to put the fraction here, not the converted number. Then it's the 52, right? That's 0.5, that's 52%. And then it's the 0.6. So that has put them in order from smallest to biggest. Any particular questions from the Year 9 one? I have done quite a few of them already. But if you have specific questions, then please tell me rather than the whole thing, because I'm not going to do the whole thing. I want specifics. 3, 13, 14. Okay, that's quite a lot of them. 3, let's have a look at. 3 I have done. I just did it a little while ago. So you can watch that back if need be. But that is all done. Question 3 on that one. 13. 13 looks tricky. Let's do that. Again, if anybody has any questions from their booklet, remember somebody said that they've got booklet 1, that's fine. But the idea of these sessions is, of course, that if you have attempted it by now, which I appreciate is quite a short amount of time from the weekend, but try to do it on, let's say, Monday, Tuesday, if you can. And that way you have an opportunity to ask questions on the Wednesday. 2 travel agents offer a week in Spain for the same original price. We've got 16C. Okay, I'll come back to that in a second. 2 travel agents offer a week in Spain for the same original price. Jane and Rosa both book early for this holiday, so it tells you what happens if you book early. Okay. Oh, this is a hard question. Jane uses Sun Travel Agent. Rosa uses Relax. What was the original price of the holiday? Okay, that's quite a hard question, that, but I shall just tell you what you do. Right. Um, okay, so they're about the same price. In one of them, you get 20% off, and the other, you get 25% off. So it's quite a difficult question, this, but the difference between these two in terms of percentages is 5%, right? So there's 5% difference. In one of them, you get 25% off, and the other you get 20% off. So there's a 5% saving on one of them. Okay, so Jane uses this one. No, Jane uses that one. And Rosa uses that one. So Jane pays more, but that's because Jane only got a 20% discount and Rose got a 25% discount, so he's got more of a discount. So there's a 5% difference. Now, 5% of the cost of the holiday was how much Rosa saved or how much extra Jane paid. And Jane paid in real money £16 more. Okay, so I want to use a calculator for this. This as a decimal is 0.05. And when you do of in maths, you're multiplying. So we're saying that 5% of that holiday, which is the saving that one person got, earned them a £16 saving in reality. So using that, we should be able to work out the original price of this holiday by doing 16 divided by that 5%. Or 16 times 20. That can't be right. It's only £320. Um, no, yeah, well, it must be. That's a little bit cheap, isn't it? So if it was £320, Jane will have got 20% off and paid £256. Rosa will have got 25% off and paid £240. So the difference is £16. So yeah, that is the answer. 320. Awkward. This question would have been easier if the amount paid was revealed. Yes, but that was the question. Oh, the amount paid by each person. Yeah, I see what you mean. It's an awkward way of asking it, which is the difference between them. Right, let me question six, booklet two, but I want to do the booklet one question because nobody has asked anything from there yet. 16C. Okay, this last one here. A newspaper reported a survey. He asked people what their favorite leisure activity. There's some information about the answers he got. Complete the table. Well, we know percentages add up to 100, so we should be able to work out what's missing here. 22 add 14 is 36, add 9 is 45, which means this must be 55% to make it all add up to 100. Write 9% as a decimal. To turn a percentage into a decimal, just divide it by 100. That's 0.09. 400 people were asked in the survey. How many people said their favorite activity was gardening? Well, gardening was 9% of everybody we asked. But we now know we asked 400 people, so we're working out 9% of 400. The best way to work out 9% of 400 is to first work out 1%. To work out 1% of any number, you divide it by 100. If you divide this number by 100, you get 4. Now, to go from 1% to 9%, we would just multiply by 9. And 4 multiplied by 9 is 36. So that is the number of people that must have said gardening for their leisure activity. Right, question 6 on booklet 2. Just a reminder for those of you that might be here for the first time. What I'm doing gets recorded and is available to watch later, should you want. Is this it? Oh, I did that earlier. Right, question 6. Booklet 2. But yes, I'll just quickly do that. 10% of any number means you divide it by 10. 1% of any number is dividing by 100. They're the two ones you definitely need to know, okay? Because it allows you to do most percentages questions. As long as you can get 10% and 1%, then you can manipulate it as you wish. But the rest of it, 20% of a number is dividing by 5. 5% of a number is dividing by 20. If you care, then the clue is that this number and the number it matches with multiply to give 100. 20 times 5, 5 times 20, 1 times 100. If that's what you wanted to do. Right, questions. Yep, I'm moving to booklet 3 now, because a few people have asked questions. So question 14, right. Let us have a look. Okay, a chemistry examination has 2 sections. Section A has 80 marks, section B has 60 marks. Alex scores 55% in section A. It's quite a hard question. I'll probably use a calculator for this. Maybe not. Right. If you did a test for us and got 55% in a test that was worth 80 marks altogether, then you can work out how many marks you got, because you would have got 55% of the total of 80 marks. I'll do this with a without a calculator. To work out 55% of 80, what I'm going to do is work out 50% first, which is 40. That's half of that number. 5% is 4, because 10% is 8, which means 55% is 44. Right. So he got 44 marks in section A. Okay. Or she. Yeah. What is the greatest percentage now that Alex can get in the whole examination? So let's say you've just done section A and you got 44 out of 80 marks. Now you're about to do section B. Now the question is, what is the best you can do now? Well, the best you can do is if you get everything right in section B. So you get all 60 marks, okay, in section B. Now, in total, added to the 44 that you've got in section A, means that you can get 104 marks in total out of the whole exam. The whole exam is out of 140. See that? 80 out 60. So what you need to do now is turn that into a percentage. So the best you can do, if you get everything right in section B, is get a total of 104 marks, because you've already got only 44 in section A. And if you get everything right in section B, which is unlikely, then you will have 104 marks out of 140. And to turn that into a percentage, this is what I would do. 104 out of 140 times 100. That turns any fraction into a percentage. And it is. To three significant figures means three of these digits. It's 74.3% because you have to round that two up because of the 8. Okay. That seems to cover everything that anybody has asked me today, and that is most of these questions. Is there anything else? Last opportunity, and then I will stop until the next session. Okay, no, fine, right. In that case, I'm going to return in 8 minutes to do the stuff for the other groups, should they have any questions on surds and indices or the sine and cosine rule. I'll be back. Hello. Right. I am going to probably go over this booklet first. If you have any questions, and I suspect if there are any Year 11s joining who did the sine and cosine rule, there are likely to be questions from that booklet because it was quite hard. If you're on Year 11 and a few people that did stuff on straight lines and simultaneous equations, then just specify that that is the booklet that you want me to assist with if you are going to ask any questions. But any questions yet? Or if you were here on you attended on Thursday or Friday, then you did electricity, in which case I also have that available somewhere. Somewhere. Oh, no. Somewhere. Yes, I do. So if you are going to ask me a question from that, then say so. Year 10, question 16, I shall do that. But again, if you need a question on the electricity stuff, then just specify it's the electricity year 10, or whatever it might be, because I have it ready to go here. So question 16 on surds and indices, I assume. Is that this one? Okay. Right. Well, let's talk about this. When you have a negative indice, negative power, which is what this is, then what it does to your big number is flips it over. That's what it does. That's all it does. It doesn't make it a minus or anything like that. It flips it upside down. So remember, an 8 or any whole number is technically over 1 as a fraction. So if it flips over, it is 1 over 8. Okay. Then the rest of this power, the 2/3, is still there. Okay. And when you have a fractional power, you need to first look at the number at the bottom, which in this case is a 3. And what that tells you to do is cube root the fraction. When you cube root a fraction or square root a fraction, you do that thing to the top and the bottom. So if I was doing a long explanation of this, then we've got our 1 over 8. That 3 here is telling us to cube root the 1, there's a 3 there, and cube root the 8. Okay. The cube root of 1 is 1, because 1 times 1 times 1 is 1. And the cube root of 8 is 2, because 2 times 2 times 2 is 8. But we still had this 2 on the top. We now need to look at that. So there's lots of bits to this question, which is why it's a really good question. The minus flips it over, the 3 cube roots it, but then the 2 on the top of that fraction tells you to square everything that you've got. When you're squaring a fraction, you square the top and you square the bottom. 1 squared is 1, 1 times 1, and 2 squared is 2 times 2, which is 4. Now, again, that's the answer to the question. So I appreciate when you're doing homework at home, I can't really stop you from using a calculator. But in principle, you need to make sure you can do that without a calculator, because if you did have a calculator, you could just do this. And it will work out the answer for you, but you need to not be able to do that. You need to do it without it, like I just did. Any other questions from this particular booklet or any of the other booklets anybody had? Oh, God, that doesn't look very nice. We've got another one. 17. Okay, there you go. Question 17. Work out A and B. Right. First of all, the B is definitely 5, and I'll just tell you why. If I gave you this question, that one, right? Completely different question. But if I gave you that question, then what that tells you to do is to apply that 2 to the 3, which squares it to 9, and apply that 2 to the x to the power 5. Now, when you have a power with another power, like you have here, you multiply them together. So that becomes x to the power 10 in that situation. But this question here that we're doing is sort of this in reverse. It's going, right, the answer is 16r to the power 20. What was the question, effectively? Well, again, with this power and this 4, we would multiply them together, and they've given us 20. So that means it's definitely something r to the power 5 outside, and that gives us that 20. But then there's this number here. There's a number here. When you put it to the power 4, you get 16. So there's a number that when you times it by itself, and then itself, and then itself, you get itself, itself, four of them, you get 16. That number is 2 because 2 times 2 times 2 times 2, I promise you, is 16. So the answer to this question is that A is 2 and the B is 5 because then it ends up being 16R to the power 20. What's the point of the 3? Is that from that earlier question that I did? I'm not sure which 3 you're now referring to. Yeah, okay. Right. So, unless you're talking about this earlier question, and it's this 3, well, that 3 tells you to cube root the numbers that you've got. Right, 4, 12, and 20. 4 is this one. So, work out the value of 64 to the power 2/3. Whenever you have a fractional power, the first thing to look at is the denominator of the fraction, the 3 in this case. What that 3 tells you to do is cube root the big number, 64. And then the top number will just mean it's going to be to the power of the top number once you get to the answer. The cube root of 64 means a number that when you multiply it by itself and then by itself again, you get 64. That number is 4. There's 4 times 4 times 4 is 64. This 2 now is still there, and 4 to the power of 2, 4 squared, is 4 times 4, which is 16, and that is the answer to that question. Why do you cube root if it's 3? You just do. That's the point. If it's a fraction with a 2 on the bottom, so that's why you look at the bottom first. If there's a 2 at the bottom of a powered fraction, fractional power, you square root the number that you have. If there's a 3 on the bottom, you cube root the number that you have. That is just the rule. That is what you do. 4, 12, and 20. 4, 12, and 20. Did I do 4 just now? No, that's that one. Oh, yeah. I think there's a problem with this question. I think the printing has resulted in this thing needing to be all the way across, and it isn't. So you can't really get that right without asking. But that's why I'm here. So this question is saying the square root of 2 to the power 6 plus 6 squared. Now, 2 to the power 6 means 2 times 2 times 2 times 2 times 2 times 2. Yeah, 6 of them. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. And 6 squared is 36. 64 plus 36 is 100, and the square root of 100 is 10. Yeah. Yeah, okay. Square root of 100 million. Okay. Firstly, what is 100 million? It is 100 followed by 6 zeros. Square root of something means that a number that when you multiply it by itself, you get to this number. Now, when you multiply numbers with, like if I do 10 times 10, what do I get? I get 100, right? So in other words, however many zeros there are just end up in the answer. So if there are 8 zeros here, and I split the 8 zeros down the middle so that I get 10,000 times another 10,000, what will happen is that I will get 1 followed by these 8 zeros. So therefore, the square root of 100 million must be 10,000, because then you get the 8 zeros. And that is all of those questions, isn't it? Any more? Any more? Surprised I know year 11s here asking me about the sine and cosine rule. Okay, more. Question 8. This one. Right, the square root of 72 in the form a root 2. So we did indices and surds. So this is called surds. Right, when you are doing this kind of question, essentially what you need to do is split the number 72 into two numbers that multiply to give 72. But importantly, what you want is for one of those numbers to be a square number. The square numbers after 1 are 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, roll them. Yes. So you want two numbers that multiply to give 72, preferably one of them being one of these square numbers. And you may recognize that 36 goes into 72 two times. Okay, so that's what you do first. Split it into two numbers, but you want one of those numbers to be a square number because a square number square rooted turns into a whole number. Square root of 36 is 6. And then you just stick this onto it. So your answer is 6 root 2, and it looks like this. Okay, and then let me just finish off part B. Right, that's a little bit harder, this. So, when you square something, what does that mean? If I said to you 3 squared, it means 3 multiplied by 3. If you have a bracket squared, then it means that you have the bracket multiplied by itself. There's two ways of doing this question. I want to do it the longer way. So if you have two brackets and you are multiplying them together, you need to make sure that everything in the first bracket is multiplied by everything in the other bracket. So the way I do that is I start with this, times it by this. Now the square root of 6 times the square root of 6 is the square root of 36. You just times the numbers together. Later we will simplify this, which I'll come to that in a minute. Let's move on. Square root of 6 times the square root of 12 is the square root of 12 times 6, which is 72. Then we move on to the next one here. That times that is the square root of 72 again. And this times this is the square root of 144. So I've just multiplied them all together. Then what can I do? I can simplify things. The square root of 36 is a whole number, 6. The square root of 144 is a whole number, it's 12. What about this bit in the middle? Well, part A of this question helps because in part A, we already turned the square root of 72 into 6 root 2. So let's do the same thing here. That square root of 72 is 6 square root 2, and this one is 6 square root 2. And then you can collect like terms together. So numbers like 6 and 12 can be added together. And if you've got 6 square root 2 plus another 6 square root 2, it's just like doing 6x add 6x. You'd make 12x. You just add the outside numbers together. So 12 root 2, and that's the answer because it looks like that, doesn't it? Something plus something root 2. Question 12. I thought I did question 12. Did I do question 12? No, I didn't. Okay, work out the value of this. Right. Firstly, to the power 4, if I said to you 3 to the power 4, what do I mean? I mean 3 times 3 times 3 times 3. So the square root of 2 to the power 4 is the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2. Okay, let's break this up slowly. Well, there's a few different ways to do this. You could actually just multiply all of these 2's together. So, and let's do that actually. So if I did 2 times 2, I'd get 4, times another 2, I'd get 8, times another 2, I'd get 16. And what is the square root of 16? 4 is the answer to this question. And then part B, we just did a expand question, but we'll do this one as well. So when you have a bracket with a squared outside, you can write it out twice and then expand it. So first term here, times it by that. Square root of 2 times square root of 2 is the square root of 4. I'll simplify it later. Square root of 2 times 3. When you have just a number multiplied by a square root something, you just put the number outside it. You don't do anything else. So it's 3 square root 2. That's all we do. Put that 3 outside there. Done. Then we move on to this 3 times it by that square root 2. Again, we just stick it outside it. And then you take that 3 and you times it by this 3, which gives you 9. Right, then this square root 4, square root of 4 is 2. Let's write it all out again. Okay, and again, now we can collect the terms that are the same. Like the numbers 2 and 9 makes 11. And 3 root 2 plus another 3 root 2 is 6 square root 2. So, of course, you need to be able to do these questions without a calculator, as I just did. However, if you wanted to check your answer, check, importantly, not to do, then if you did something like this, which is the question, then it should give you the same answer that I just got. It does. Look at that. So it's a good way of checking. Um, question 11. Is this all of them? We're doing all of them. Okay, it's fine. Work out the exact value of this. Okay. What does a negative power tell you to do? A negative power tells you to flip over whatever you've got. And when it's already a fraction, it's very easy. Just flip it upside down. Okay, that's what the minus does, just the minus. But there's a 3 still there. That 3 is telling you to cube the top and cube the bottom. 4 cubed, which is 4 times 4 times 4, is 64. And 3 cubed, which is 3 times 3 times 3, is 27. And that is the exact value of that. I'm going backwards to 10b. Yes, 10b, I can do that. Rationalize the denominator. For some reason, don't ask me why, we don't like having these root things on the bottom of a fraction. So there is a way to change how it looks so that that root thing is not on the bottom of the fraction. It ends up on the top, but it doesn't, it's off the bottom. That's basically what we're trying to do. And the way you do that when you have a root on its own like this on the bottom is you multiply this fraction by that over that. Okay, in other words, whatever you have on the bottom, just twice, like on the top and the bottom. Okay, just to be clear, if I typed this into the calculator, what would I get? You just get 1, because if you divide a number by itself, you just get 1. And if you times by 1, what happens to a number? Nothing. It doesn't change. We're not changing the value of this number. We're just making it look different. It's a presentational thing. I'll explain what I mean. If you multiply fractions together, what do? You multiply the tops. 12 times root 3, you just write 12 root 3. On the bottom, you get the square root of 3 times the square root of 3, which is the square root of 9, but the square root of 9 becomes a whole number, which is 3. And then, so see we've rationalized it. That means that third is not on the bottom anymore. It's ended up shifting to the top. But there's a simplification we can do as well, because 12 divided by 3 is 4. So the answer is 4 root 3. Again, just as a little check for you, for your benefit. Calculators also do this for you, which is why all of these questions appear on non-calculator exams, usually. And so if you do 12 over root 3, the calculator will do what we just did. And it'll tell you that it becomes 4 root 3. If there is a question. Okay, I'll come to question 15 soon. Right, let me explain this question. If there's a question like 3 square root 2 squared. Okay, this is the question you are referring to. Okay, so I'll tell you how I would do this question. If I had 3 square root 2 squared, squaring something means you multiply it by itself. Okay. Now, so that's what I've changed it to. Okay. Now, a number and a third stuck together, a bit like when you have 3x stuck together. What does that mean? It means 3 multiplied by x, doesn't it? So I'm going to change that to 3 times the square root 2, just to show you how I'm thinking of this. Okay, so that's actually 3 root 2 means 3 times square root 2. I don't know why this is at an angle. Sorry, my laptop's at an angle. Look at that. 3 square root 2 times root 2. I've just changed the 3 to it with the times in the middle. So now they're all being multiplied together. And then what you're allowed to do, remember, if you're timesing lots of things together, like 2 times 3 times 4 times 5, it doesn't matter what order you do it in, does it? You could do 4 times 2, and then times it by 5, and then times it by 3. It would still be the same answer. So in the same sort of way, what I can do is just shuffle this around a little bit. So I'm going to put the 3 and the 3 together, 3 times 3, and the square root 2 and the square root 2 together. 3 times 3 is 9. And the square root of 2 times the square root of 2 is the square root of 4, which becomes 2. And therefore the answer is 18. You did mention 18 somewhere. Yes, there you go. That's a long-winded explanation. But yes, what you just said is kind of correct, which is you could very quickly go, well, 3 squared is 9. And the square root of 2 squared is 2. So 9 times 2 is 18. So yes, in a long-winded answer to your question, yes, you can do it either way. You get the same answer. Um, Physics, electricity, homework. Yes, absolutely. I'll do that in just a moment. 15. So let me just get through this math. A couple of math questions left, and I'll just then move over to that. And then I will try to go through the question about nuclear fission. I don't think I'm going to do the required practical for energy, mainly because it's called specific heat capacity and it's a pain. Um, right. But 6 and 7, let me see if I've already done those. No, I haven't. I really don't feel the need to do these questions. I'm not going to do 7. Um, 6 I can do. And then I'll do the last one, which is 15C. Um, the square root of 12 plus the square root of 75. So the point of these questions is that with any surd, well, not any surd, but with a surd with a big enough number in the middle, you can simplify it. So when you simplify these surds, you're trying to find two numbers that multiply to give that number in the middle, like 4 and 3. But crucially, you want one of the numbers to be a square number. So a number that when you square root it, it becomes a whole number. The square root of 4 is 2, and then you just stick the other thing onto it. So the square root of 12 simplifies to 2 root 3. The square root of 75 as well, you need to find two numbers that multiply to give 75, preferably one of which is a square number. Now, I know that 25 is a square number, and 25 goes into 75 three times, which means that that square root 25 can become a 5, and then you can stick the root 3 onto it, which means that the square root of 75 becomes 5 root 3. 2 root 3 plus 5 root 3 is 7 root 3. Right, and the last question I want to do on this is 15C. Ah, okay. Again, I shouldn't need to do this, but I'll do it. When you have questions such as this, multiply the numbers together. 5 times 3, 15. Multiply the x's together. When you multiply things with powers that are the same, then you add the powers together. So you can add the 3 and the 4 to make 7. Oop. And same with the y's, you can add, it's really bad 7. You can add the 2 and the 3 together to make 5. And you get 15x to 7, 5 to 5. That's the answer to that question. Right, I'm going to revert to other things. There's quite a lot of that booklet now. Some people still did electricity because of the timing of our lessons. So I'm going to just revert back to just doing one of these questions. Question 3E. Let's see what that looks like. Yeah. Well, luckily I've got an answer to this question. So, this question was about a washing machine, which has a metal case, and something went wrong, and it causes the live wire to touch it, basically, right? And which means that your metal case on the outside now has got electricity running through it, which means that if you touch it, you could get an electric shock. Well, and that's part of the answer, actually. The earth wire is not connected. The earth wire, remember, is like a safety wire, and it takes any electricity that doesn't belong in the right place down to the ground to kind of try and prevent you from getting a shock. But if that's not connected, now you could get an electric shock. And the answer that you want to say is that the reason it would not be safe to touch the metal case is that you could get an electric shock, firstly. Why? Because current will flow through you when you touch it. And that's what it means. It looks for a route to go down, and you are a route, unfortunately, for electricity to go down because of a biology reason. We're made of nerve cells that transfer electrical impulses. But you can get an electric shock because the current can flow through you. So that is the answer to that particular question. Right, there is a question now about the year 11 maths. Is there any particular question that you're referring to when you say is cosine used when there are two sides between the angle? Only because it's a slightly vague question that you just asked. But it depends. So it depends. Are we working out a side of a triangle or are we working out an angle? I think we're working out a side based on your question. Where am I? There. Okay. Um, oh, good. Well, yes, good. I'm glad you're finding it easy. Although, to be fair, I would challenge you, only because I know this, but I would challenge you to try I don't even know what question number this is because there's no question numbers on these. Page 12. this particular question, right? It may seem easy, but I will be surprised if people get the right answer to that question. Put it that way. Anyway, in answer to your question, if I was doing the cosine rule, if I gave you this triangle, um, then yes, if I want to work out this side, then with the cosine rule, I would effectively need these two sides and this angle. Because if that's A, that's capital A, and then these two are B and C, then the cosine rule requires a B, a C, and a capital A, effectively, or two sides and the angle in between them. That's also, just off topic slightly, the exact same information that's required to work out the area of any triangle, two sides and the angle in between. What did you get for that question answer? Question 12. If you've done it. Okay. I'm not sure which quadratic you're talking to, but anyway, we'll leave that. If you do get it, then we'll do it. Right, anything else? Anything else anybody needs? You can keep asking me for the next little while, but what I'll do is I will, just because someone has asked, talk a little bit about this physics thing called nuclear fission. And also a paper one physics, and also just to be clear, if you're asking me about paper one physics, just so you know, when you ask those questions about the paper number, just make sure you specify which exam board. And I only say that because the content on different, the order of content on different exam boards is different. What's on paper one AQA is not necessarily paper one Excel. I can, it depends on your question on the AQA, yeah, fine, and then I know. Year 10, if you have a specific question from the year 10 that I've not yet answered, and it's not, and I don't think it's reason, I don't think it's too easy a question to ask, then you can ask and I will answer it. I'm still here, so sure. But again, remember the purpose of these things is not for you to do the homework live, which is, I suspect, what is happening again. Number 10 on the thing booklet, right? I'll do that first, and then I'll find there's plenty of time, right? So I can talk about the physics. So in AQA Triple Science, just so you know again, make sure you know the topics in physics paper one, which are, top of my head, energy, electricity, particle theory, and atomic structure or radioactivity, which is where the nuclear fusion fission comes from. But they are the four topics on it. I don't know why I know these things. Number 10. Where, oh, God. I seem to have lost my page numbers. So you're going to talk about page it's on? Sorry, question numbers. Tell me what page question number 10 is on. Why are they gone? Not turned up. 12. Okay. Ah, that was the question that I was referring to. Okay, so it's quite complicated, this question. And to be fair, you wouldn't. What I mean by complicated, I mean, it's actually really easy to get three of the four marks, which is fine. Like, you don't have to stress about these things. But I'll just tell you why this is complicated. At least the last part, the very last mark is complicated. Because the question says, work out the size of angle ABC, which is this angle over here. Okay. All of which work. Depends, I'll show you how to do it, and then we can determine it. Right. One thing that I said to the people that I have taught, and if you watch the video of this being explained, which I have done at some point in the past, and again, if you don't have access to these things, please contact us because you all have technically access to some very, if I do say so myself, very good videos relating to these topics. This is a sine rule question, right? What I always say when I teach this topic is because the sine rule is A over sine A equals B over sine B equals C over sine C, which is not really that relevant. I always kind of go, okay, whatever I'm working out, which is this angle here, I'm going to label it A. So any existing labels I just get rid of, because that can confuse things a little bit. If that's capital A, this is little a, and that's little b, and that's capital B. Whichever way you do it, you should end up with something that looks like this. Sine X or A or whatever over 20 equals, and remember, sorry, when you're working out an angle, you're better off flipping this formula over as I have just done, because it just makes it slightly easier to rearrange. So sine A over 20 equals sine B or sine 35 over 12. Okay, so I'm going to multiply by 20 here. Yeah. And it will give me, from memory, about 0.955. Look at that. Sine A equals 0.955. Call it 0.96 for now. Okay, right. And then what do you normally do next to find the answer? You just do that shift sign thing on your calculator. And I get 72.9 degrees as my answer. And then I would normally, most people would just move on. Why is that not the correct answer to this question? Just to be clear, that is as much as I would expect you to do at this point. There is just a very little niche problem with this final answer, which is why you get 3 out of the 4 marks, because you've done most of the work. We know what the problem is with my answer? Nope, it is three significant figures, 72.9. So my calculator said that, and I've done it to three significant figures, 72.9. There is another problem with my answer, if you read the question again. It is not obtuse. Correct. Obtuse angles, which you learn basically from the very first time you ever learn about what an angle is an angle that is between 90 and 180 degrees. That's what an obtuse angle is. My answer is not between 90 and 180 degrees. So just to be clear, I'm going to repeat this again. What I'm about to tell you is a relatively advanced thing. If you don't get it for now, it is not a big issue. Okay. As I said, if you did exactly what I've just done now, you would get 3 out of the 4 marks. Fine. Right. Um, oh, sorry. Okay. So let me tell you what this is. What I'm going to do is introduce you in some cases or remind you of what a sine graph looks like. Can I do this on graph paper? No, I can't be bothered. Um, this is a graph of y equals sine x. It goes up to 1 at its highest point and down to -1 at its lowest point. And each of these little intervals is 90. So that's 90. That's another 90. So 180. That's 270. That's 360. That's 450. We keep adding 90. You don't keep doing this, but it goes forever, basically, to the right. It's like a wave, and it just keeps going. Okay. Right. When you type in things like sine 20 into your calculator, I mean, you don't really think about what it's doing, right? You just kind of do it, when you've done trigonometry or whatever it might be, or when you're doing the sine rule and stuff. You don't really think about, you just type it in, right? And you just do it. But let me explain to you what the calculator is doing. When you type in sine 20 into your calculator, what it does is it basically goes to this graph that I have just drawn. And it goes to where x is 20 on the graph, which is roughly, if that's 0 to 90, then 20 is roughly there, roughly. Okay. And what it does is it reads until it hits the graph, and then it tells you what this value here is. So sine 20, it's saying it's 0.34. That is about 0.34, right? Because this whole thing is 1 to the top. So it's saying it's about 0.34. That's what the calculator is doing, okay, when you type in sine anything. Okay, and same with cos and tan, they're just different graphs that it's just reading off. When you do a question like this, sine 20, you're basically working out what the y coordinate is when the x coordinate is 20. It's like when you read off, any graph, x is 20, what is y? But when you do this kind of thing, when you use the inverse button on the calculator, you do the opposite thing. You tell the calculator what the y coordinate is, 0.96, which in this case is quite high up, right? So let's just say it's there. 0.96. Okay, so quite close to 1. And you're asking the calculator to go, okay, when y is 0.96, what is the x coordinate? And what the calculator does is it goes to the graph, reads across until it hits the line, reads down, and tells you what number comes here. And that's why we got 72.9. As you can tell, that looks roughly accurate based on my sketch. It's close to 90. That's what it has done. Okay. So remember, the question that you asked the calculator was, on this graph, what is the x coordinate when the y coordinate is 0.96? And so what it did was it read across until it hit the line and then read down. However, that's not the only answer to that question, because surely, because this line kind of goes up and then down and then up and then down, there's another answer to that question here as well. Right? You see what I mean? Because the y is going straight across 0.9, it goes across forever, and it hits that line in lots of different places. And so that is another answer to that question. Okay? Let me just get rid of this if I can. Yeah. And actually, there's infinite answer to this question because it continues even over there, but we don't need all of those ones. The answer that we're looking for is the one that's between 90 and 180. In other words, we want this answer here for that obtuse angle that we talked about, not this one here, not the 72.9. We want the next one. How do you get to the next one? Well, because of the symmetry of the graph, it's actually really easy because the distance between here and here is the same if I had drawn it a bit better. The same as the distance between here and here. It's meant to be exactly the same. See what I mean? It's just that I've drawn it weirdly. And so to figure out what this value here is, surely it's the same distance before 180 as this was from 0. So if this gap here was 72.9, this gap is 72.9, which means that to get to this answer, I could just do 180 minus that answer that we got before, which is 107.1. That is a complicated question. It's just that one mark is complicated, just to be clear. It is not, anything else. Well, I'll tell you why it's worth it, because you don't need to do all of that. Just do what I'm about to tell you. If you ever come across that again, where you see that problem, which is that you've got a number, an angle that is not an obtuse angle, and you need it to be an obtuse angle, all you need to do, forget the graph that I just did, you need to do 180 minus whatever answer you've got, and that'll make it go from an acute angle to an obtuse angle. So yes, that is worth it for 1 mark. My explanation was longer, but if you were doing this, you would just do 180 minus that answer. But that's the reason why you would do it. I was trying to explain the reason behind it. So yes, that's all you need to do. 180 minus the answer will get you to the correct one. If you have any aspirations to do A-level maths in the future, then you will do a lot of this. Okay. Hence why I know it quite well. Now what? Where are we? Some electricity questions. 1F year 10 electricity. Okay, let me go back to that. Oh wow, there's a lot of stuff going on here. Okay, I'm not reading too much here, but the equation that links these things is V equals IR. The question says calculate the resistance of the LDR. So resistance is voltage over current if you rearrange the equation. The voltage is 5.5. The current, you have to be careful because they gave it to you in milliamps. So to turn that into amps, you divide it by 1,000. Okay, that's 0.0125 amps. That is what comes into here as your current, and then you do 5.5 divided by that. Feels like a lot of marks for that question, but it is the answer. Right, since there's no more, I will just briefly talk about, oh no, there is something else. No, there isn't. The physics stuff to do with paper one. If you have any questions in the meantime on your homework while I'm here for the next 10 minutes or so, then feel free to ask. Okay, so I'm just doing this because somebody has asked me about physics paper one. In physics paper one, for those of you when you get there, some of you this year, um, if it's AQA, then you will have energy. There's quite a lot of equations, but remember, you get given the equation, or you should, so let's not stress about that too much. Um, and yeah, okay, stuff about fossil fuels and renewable and non-renewable stuff. Everything to do with electricity, which you should be relatively fresh on, relatively speaking, which is there. We didn't do much on static electricity, but that is in triple science, which we'll get to. Just have a read through it, probably. This particle theory topic has a required practical, that one I will talk about mainly because I like it, which I will talk about in a second, which is about finding the density of an irregular object. And then the fourth topic. So this is mostly solids, liquids, and gases, but just be careful. There are some weird things in here to do with specific latent heat and specific heat capacity. That would be the thing that I would just brush up on. And there is a required practical on specific heat capacity, not in here, but it's in topic one, somewhere around here. It's in there. And then the topic that you mentioned was nuclear fission, which is the reaction that takes place in a nuclear power station. A nuclear power station, remember, is a way of generating electricity using nuclear fuel, nuclear energy, rather than fossil fuels. There are advantages of using nuclear fuel over fossil fuels in that they do not emit any harmful gases that affect the greenhouse effect and global warming and so on and so on. Nuclear fuel releases loads and loads and loads of energy. It is very cost effective. Do try and use the word cost effective if you are talking about advantages of nuclear rather than cheap, because it's too vague a word. Cost effective is a better phrase for that because it explains that it's cost effective in that the amount of energy we get out of it is so high relative to how much it costs. And that is better because cheap on its own doesn't really tell you that. However, the problem with nuclear energy is that there is always some nuclear waste following the process. And that nuclear waste remains radioactive for a long time. And you have to dispose of it away from people. And they often like put it in boxes and bury it underground far away. Because if it's near people, then the radiation emitted can get into our body and cause problems and so on. Okay. But your question was specifically about what that process is that's happening inside. It is called nuclear fission. With nuclear fission, what we do is we get some of our nuclear fuel, which is uranium usually, and we fire a neutron at it. And when that neutron hits is absorbed by this nucleus, it causes the nucleus to split. Fission literally means splitting. That's what's happening. That nucleus splits, as you can see, into two smaller nuclei. That split releases loads and loads of energy. But there's more because not only does that split result in two smaller nuclei, as you can see here, it also results in more neutrons being released. And those neutrons then do the same again. They hit another nucleus, causing it to split and releasing loads of energy. And that releases more neutrons, which go and continue to do the same thing. This is called a chain reaction. Sometimes in an exam question, you have to draw some of this yourself. Just make sure you draw a few cycles of it to demonstrate the fact that it continues on. Then the only other thing really to say about this is, well, given that this is called a chain reaction and it keeps on going and keeps on going, how do you make it stop? Well, what you do is you use these things called control rods. Basically, what they do is we just put a rod straight down the middle here, and that absorbs these neutrons so that they don't hit another nucleus and cause the whole thing to continue. It basically slows the whole thing down and eventually stops it. So it's these things called control rods, and that's pretty much it. Not a huge amount else to say um, about that. We've got a question. Can you remind of something that is related to the sun? Do you mean nuclear fusion? Is that what you are referring to? Can you remind me of something that's related to the sun? I suspect that's nuclear fusion. Based on what I was just saying, I suspect you're talking about nuclear fusion. Nuclear fusion is as I said, it's the opposite of nuclear fission. Fission is the splitting of two nuclei. So one, let me check what it says. Hydrogen, yes, it is indeed. That's what it is. Right. So nuclear fusion is the opposite of nuclear fission. In nuclear fission, we have a nucleus that is splitting into smaller ones, whereas in fusion, we have smaller ones joining together to create a bigger one. Right. Literally the exact opposite. And the way that works is two hydrogen nuclei fuse together to make a helium nucleus. Um, and in the process, loads of energy is released. So again, both nuclear fusion and fission release loads and loads of energy. Um, However, the problem with fusion is that it requires huge amounts of temperature and pressure for it to actually happen. And we haven't been able to replicate those things on Earth, like that very high temperature or the very high pressure that we need to make this thing happen to release all of that energy that we could then use, to give you electricity or to warm your home or to power your cars or wherever it might be. It doesn't do that because we can't recreate those conditions. The places where it does happen is on the sun and on all stars, because remember, the sun is just a star. Um, Stars stay as they are, hot and bright, because this process of nuclear fusion is constantly happening on them. And that's releasing loads of energy, and that's what's keeping them hot and bright. But up there, it is very hot and there are high pressures. That's why it can happen. We haven't been able to do that on Earth. That's it, really. Not much else to say. Right. And then the required practical that I just wanted to briefly talk about was, that's the last thing I'll do, um, which is in the topic of particle model of matter. There is a required practical in physics involving finding the density of an irregular object. Okay, by an irregular object, we mean like a rock or something, okay, as opposed to a regular object, which would be like a cube, okay? A regular object basically means that we can find its volume using a ruler. I could measure this side, measure this side, measure this side, multiply them together and get its volume, right? Similarly, if I had like a cylinder or something, there's a mathematical formula for finding out its volume. We don't have that for a rock, okay? Because it's an irregular object, okay? If I want to find the density of this object, there is a required practical in which you can get a question asking you for 6 marks, how would you find the density of this object? And I've seen questions with rocks. I've seen questions with like a chess piece, like the what's it called? The knight? No. Oh yeah, the horse and chess. Can't remember what it's called. It's called the knight. Um, like literally one of those, a picture of one of those, and how do you find out its density? Because it's an irregular object, because there's no obviously mathematical formula, because it's a weird shape and stuff like that. How do you find the density of irregular objects? Firstly, there is a formula that you will get given. Density equals mass divided by volume. So in order to work out the density of any object, I need two numbers. I need the mass and I need the volume. To find the mass of this object is very easy. All you do is put it on a scale or a balance and it'll read off the number that tells you its mass. Done. We've done half the answer. Okay. The tricky thing is, how do you find the volume of an object like this? Because, as I said, there's no easy ruler mathematical method to figure out its volume. You use something called a displacement can or a Eureka can, and it looks a bit like this. You may have seen one. Okay, Eureka can or a displacement can. Okay, and what you do with this can is you fill it up with water all the way to this spout. There's a spout here. Fill it up to there. You put then a measuring cylinder just here. Because remember, a measuring cylinder does measure volume, but it only does it for liquids. You can't drop a rock into there and get its volume because a liquid, remember, changes shape to take the shape of the container. That's what liquids do. So we can measure volumes of liquids using a measuring cylinder or a measuring jug if you have someone in your kitchen. But you can't do it with a solid object. But if we use this, we can do it. Because if I drop this rock into this thing, right, the level of this water now will automatically rise because this rock is now taking up this much space inside this liquid. And so the amount of space it's taken up has basically removed water from that much space, and that much water has risen up. And that, because it's at the level of the spout, will go down the spout and go into the measuring cylinder. And we will have some water in here. And the volume of this water, which we can now measure because of the measuring cylinder, must equal the volume of the object or the rock in this case. Because that's the whole point. That rock has taken the space of that much water. So that much water has come out. So the volume of those two things is the same. And we can now measure the volume of this water, which will give us the volume of this rock. We then take that volume and put it into this formula, and we have the density of the object. That is one of the required practicals, which is in AQA Physics Paper 1. The only other one, as I say, I think is specific heat capacity I can think of, and I can't remember off the top of my head. Oh, electricity's got like two, but yeah, I forgot about that. Electricity's got a couple. But that's it, I think. Right, given that there are no further questions, I think I will leave it there for today. You will this weekend, if you attend on a weekend, on Saturday, Sunday, you will be doing some more maths. For year 10, it's to do with factorizing, I think. And for year 11, it's to do with something called proof, which is reasonably complicated, which we will talk about on Wednesday. Right, I think that's it. If anybody have any more questions, I think we're it. Yeah, okay, cool. I will see you next time then. If you do have any other questions, remember we have a WhatsApp number, which some of you use more than others, but feel free to message on that if you need anything. See you later.